Mango Math presents Q, a first grade game. Q is a first grade game that falls in the standard of algebraic thinking. And it's an algebraic thinking game that applies properties of operations as strategies to add and subtract. Q has some math terms to help with increased understanding. Add-ins, numbers added to create a total. Sum, the result of addition. Difference, the result of subtraction. Equation, mathematical statement containing an equal sign. And an inverse operation, which is reverse or opposite operation like addition is to subtraction. The supplies that come in the pouch along with the instruction sheet and directions will be a deck of cards. And notice that there are no face cards in this deck of cards. It has 0s, 11s, and 12s instead of the usual face cards. It will have bicolored counters. And then there'll be game boards. This one is for the difference from 10, differences with 9, and the differences with 11. So those will be used with the game. Q is a great game that can be played with 3 players. 2 will be the players and 1 will be a dealer. You need the dealer because the game gets going rather quickly. The dealer will take the deck of cards and take out the 11s and 12s because we're not using those right now. Students will be working on just creating sums that make 10. The dealer will place 9 cards face up for all the students to see and the players to see. And once he says go, players are to draw any 2 cards out of that 9 that equal the sum of 10. So they will, as soon as they see them, they'll grab the 2 cards, place them over with their side until they make the sum of 10. Once the dealer has replaced the cards with new cards, the cards that have been taken out with new cards, the students will continue to draw out cards, making the sums of 10, and the dealer will replace those numbers. If there is nothing in that 9 that makes the sum of 10, the dealer can deal out 3 new cards onto that, so they have a total of 12 cards, and then the players can continue playing, drawing out the sums that make 10. But once those 9, we want to get back to that original 9. We don't want to have more than that, so we want to make sure that we're always, if we're adding on to the 12, that we're getting back to the original 9. Once the game is finished, the students will pair up their cards so that the 2 cards will equal the sum of 10 again, and make sure that all their pairs are matching, and that player with the most matching cards wins. If they have cards that are not matching, I usually give those to the judge, and those become the judge's cards, and no student or player can count those. The use of the game boards is to add a little bit more challenge and to kind of slow down the game and get students to think about inverse operations. In this case, they'll have the game board that has a 10 chart. And once they grab their pairs, let's say they had a 6 and a 4, they can choose to cover up 10 minus 4 on the game board, or they can choose to cover up the 10 minus 6 on the game board. And but they have to choose one or the other. The other player will then have the opportunity to do the same thing, the 2 and the 8, and they could do 10 minus 2 or 10 minus 8 and cover those up on the game board. This is just to slow down the game a little bit and get to have the kids thinking about inverse operations. This doesn't have to be done the first time they play the game. It can be added on after they've gotten very versed at their operations, their sums that make 10. One of the reasons we work on the sums that make 10 so much is if you look at this addition chart, and we have addition 1 through 10 on there, and the students learn their addition facts of 1 plus a number, so 1 plus 1 or 1 plus 2, and 10 plus a number, 10 plus 1, 10 plus 2, which are a little easier for kids to understand. When we get to the sums that make 10, you'll see those in the diagonal in the darker pink. The students will have those sums down. And then when we add on to this game, we'll start talking about after they've played sums of 10 and they've gotten that down really well, you can say, what's one more? Let's make sums of 11. And there's a game board for the sums of 11, and you include the card 11 into the deck, and they'll now look for sums that make 11. Students will slow down a little bit when they do this because that isn't as familiar, but what you want them to think about is, if I know 2 plus 8 is automatically 10 because I've worked on that and I've got my sums of 10 down. If I see 2 plus 9, 9 is just one more than 8, so that's going to be 11. So you want them to think of that adding on. And I would do that first. The adding on of a number is easier to do than your sums of 9, which is taking a number off. So after I've played the 11s a number of times and they've got their sums of 11 down, I would then go to sums of 9 and having the students think, okay, if I know that 4 plus 6 is 10, if I see 4 plus 5, I'm going to know that's 9 because it's 1 less than 10. So this is a strategy students can learn. And as if you can see on the chart, they'll start to fill in more of their knowledge of their sums facts, addition facts. And from there, students can work on their doubles. 3 plus 3 is 6, 4 plus 4 is 8, and so forth, and do the same with that plus or minus 1 in order to get those sums down. And then you'll see on the chart there's only a little bit of black left, and with those black ones you will have, we filled them in, and you'll see that there's yellow ones, which is 9 plus 3, 9 plus 4, 9 plus 5, 9 plus 6, and 9 plus 7. And that, if the students are thinking 10 plus a number, then it's going to be 9 will be just one less than that. So it's still the strategy of one more and one less. And from there, all they're left to memorize is 5 plus 2, 6 plus 2, 8 plus 4, 8 plus 5, 7 plus 5, 4 plus 2, 5 plus 3, and 6 plus 8. And so those aren't that overwhelming. And out of those, there's a strategy on the 7 plus 5, and the 4 plus 2, and the 5 plus 3, and the 6 plus 8. If you think of what number falls between those two numbers, the number between 7 and 5 is 6, and I double 6, I've got 12. The number between 4 and 2 is 3, I double that, and I have 6. The number between 5 and 3 is 4, I double that, I have 8. And the number between 6 and 8 is 7, and I double that, and I've got 14. So there's strategies to get students to learn their math facts other than counting on their fingers, which I want to make sure students get off their fingers, because once they start using their fingers to count, all they're doing is counting, and they're not learning how to add. And we want students to understand how numbers work, and we want them to be able to add in their heads and have strategies for doing that. Some guided questions to help promote critical thinking is: list all the add-ins that make the sum of 10. You want to make sure those are down like the colors of a rainbow. And list all the add-ins that make the sum of 9, and list them for 11, and have them tell you strategies for remembering the sums that make 9 and strategies for remembering the sums that make 11. And what do you notice about the add-ins that make 9 and 11? Those are those strategies. We want them thinking about those numbers. It's a great game. Kids love it. I guarantee you they'll want to play it again and again and again, and it's a great way to get those addition facts learned.